Hi, in this lecture video, I'll be discussing the acid and base reactions of alcohol. So to quickly recall, we can see that alcohol are weak acid and weak base. So they can behave as both. And substances that can behave as both an acid and bases are then referred to as amphoteric substances. And because alcohol are weak acid and weak base, they do not undergo acid and base reaction easily unless we take them and we react them with a very strong acid or a strong base. When we take an alcohol and react this with a very strong base, then the strong base will be able to pick up the proton from the alcohol and making this alcohol right here behave as an acid. And similarly, if we were to take an alcohol and react this with a very strong acid, then the strong acid would now force the alcohol to behave as a weak base. And so basically, in order for alcohol to behave as acid and base, we need to react them with very strong acid and strong base. So strong acid are required to protonate the alcohol. How strong of an acid are we talking here? What kind of acid would be suitable? Then the answer, anything that have a pKa lower than 3. And again, please remember that the lower the pKa, the more strong of an acid it would be. Okay, so we need a strong acid, one with a pK lower than -3. Why -3, you would ask? And the reason why as follow. Here is our alcohol. Once this alcohol right here is protonated, it will then become the alkoxonium ion right here. So we call this the alkoxonium ion. And this alkoxonium ion right here, a lot of time they have pKa around -3 or -2 or -3, but roughly around -2 to -3. And in order for us to then produce this alkoxonium ion, you would then need a strong acid, right, with a pK about -2 or -3 in order to make that happen. So that is the reason why right here is simply due to the fact that this pK right here of this alkoxonium ion is about -2 to -3, and therefore we need to add an acid that is stronger than that in order to make that happen. And similarly, in order to actually deprotonate the alcohol, and in this case right here, deprotonate alcohol is referring to the acid property of alcohol. To make the alcohol behave as an acid, we need to treat this with a strong base. Okay, and so if we were to take this with a strong base, we'll be able to deprotonate this alcohol right here and convert this into the alkoxide. What kind of chemical reagent can we use to deprotonate an alcohol? Then the answer, any reagent in which is corresponding alcohol will now be at least 16 or 18, right? So basically we need to have a reagent that once it come in to deprotonate the alcohol already, then its pK of the corresponding acid would now be higher than the pKa of the alcohol. So something with a higher pKa. So any strong acid with a conjugate base having pKa higher than 18 can be used effectively to deprotonate the alcohol. An example of those type of substances as follows. First, hydroxide and alkoxide. So if we were to take an alcohol, where let's say here in this case right here, ethanol, its pKa is now 15.9. When we take this and react this with hydroxide will be able to come in and deprotonate this alcohol right here and convert this into water. So here in this case right here, the pK of water is 15.7 versus this pK of this alcohol right here is only 15.9. So you can see they have very similar pKa. So here in this case right here, equilibrium would go back and forth between these two, where we would then see that 50% would exist in this and the other 50% roughly would exist in the other form. So hydroxide or alkoxide are actually not very effective in in deprotonating alcohol because they will only be able to deprotonate about 50% of the alcohol, okay, but not completely 100%. So please be aware of it. Yes, we can use hydroxide and alkoxide to do it. They simply are not very effective to deprotonate 100% of the alcohol. The other reagent that will be very effective, and in fact this will be able to deprotonate 100% of the alcohol, will then be the amine. NH2, we can have sodium amine, or but amine are very effective in doing that. So here in this case right here, again, if we were to take an alcohol and react this with sodium amine, the amine will be able to come in and deprotonate this, because the corresponding conjugate acid of this amine was then ammonia, and ammonia has a pK of about 35. So that is significantly much higher than the pK of the alcohol. So therefore, we would then have equilibrium that is very much pushed forward to the product side, to the formation of this ammonia right here. And another example of reagent that can also be effective in deprotonating alcohol would then be hydride. So we can hydride come in various forms, so they can come from sodium hydride or lithium aluminum hydride. So there are several sources of hydride. But if we were to take a hydride and react it with an alcohol, it can effectively deprotonate up to maybe 100% of all of the alcohol. And the reason why as follows, again, here's an alcohol right here with pK about 16. When we take this, react with the hydride, the hydride will be able to come in and deprotonate this alcohol, and this would then become hydrogen gas. Now, this pK of hydrogen gas right here is about 36, so much higher than the pKa of the alcohol. So that's why equilibrium is very much pushed to this product side right here. And another thing that makes this hydrogen gas right here become so effective is because it is producing a gas. In a way, it basically bubble out of solution. And if we think about the short-lived principle, this basically the removal of the product would also push equilibrium to the product size as well. So therefore, hydrogen gas or hydride would be a very effective tool in deprotonating the alcohol. And another chemical reagent that can also be used to deprotonate alcohol are basically metal. So we can use lithium metal, sodium metal, or potassium metal. And so this deprotonates alcohol basically by performing redox reaction. So it actually is a redox reaction that actually deprotonates the alcohol. So here in this case right here, when we take this and react this with a metal, the metal would actually be given an electron, so it would then come in and actually give the electron to this oxygen right here, right? And also give the electron to this hydrogen as well. So this is basically very much similar to a single replacement reaction that we have learned in general chemistry, where the sodium come in to replace this hydrogen, and this hydrogen right here would then become an element, and in the elemental form, it is a hydrogen gas. So that's what happened here in this case. Okay, so the sodium is actually given an electron to the hydrogen, and in the process of that is then deprotonating this alcohol right here. So that is another way how to remove a deprotonate in alcohol. So there are 4 ways right here. And again, so I want to mention this. Remember that again, that hydroxide and alkoxide can be used to deprotonate the alcohol. It is thus not as effective.